Hey guys, welcome back to Worms Maths Academy. Right, now we're going to be looking at derivatives using first principles. I don't really ever recall them asking a question in the exams. However, it's always good to know where derivatives actually come from, so where they're based from. Okay, so what I've done is I've just drawn any graph here, and if I wanted to work out the gradient at a single point, well, we can't. Well, we can actually magically do that, but we don't know how to yet, or maybe we do. But so let's say this is the point x, and then we would say the y value is f of x. I think I need to get a new pen. I don't like this one. F of x, and then I have another point here, which is x plus h, and there's my y value. So I've got the point x, f of x, x plus h, f of x plus h. Okay, if I found the gradient between, these 2 points, it's a bit average. So if I found the gradient between those 2 points, that'd be a reasonable approximation for what the gradient is at this point. However, the tangent itself, I think, would look more something like that. So it's going to be a fair bit off. Like it's not going to be miles off, but it's going to be a fair bit off. So what we do is we then make h a little bit less. So just say if h was 1 there, we would then make h equal 1/2. Then we would move it in again and make it equal 1/4. And slowly this point moves across. So if we get a tangent there, or not a tangent, if we get a chord there, and we get another chord there, and if we get another chord there, eventually, if we let h approach 0, we're going to end up with the exact gradient at that point. So that's why we have the limit as h approaches 0, f of x plus h, well that's y2, f of x is y1. On the bottom we would have x plus h, which is x2, minus x, which is x1. So x, which is x1. Okay, from here, the x's would cancel, so that's where we end up with this formula to find the gradient, or the instantaneous gradient, or the gradient at a single point. So let's get rid of this. And let's have a look at our formula. So we've got f of x already. For this formula, we need x plus f of x plus h. So we say f of x plus h is equal to, wherever we've got an x, we replace it with an x plus h. So 4x plus h squared plus 3x plus h minus 6, which is 4x squared plus 2hx plus h squared plus 3x plus 3h minus 6, which is 4x squared plus 8hx plus 4h squared plus 3x plus 3h minus 6. Okay, so f dash x is this formula, the limit as h approaches infinity of 4x squared plus 8hx plus 4h squared plus 3x plus 3h minus 6 minus f of x, and we know that that's f of x. You've got to put a bracket around it because there's more than one term. This is where if you stuff something up, it's generally there, or you don't know how to expand properly. Over h. Okay, so here 4x squared and 4x squared cancel. X, 3x will cancel because I've got a negative out the front. Negative 6 plus 6, they cancel. So we are left with the limit as h approaches 0. Now on top we've got a h in everything, which you'll always have. So h, I mean with a polynomial, it could be different with like sine, cos or tan or something like that. 4h plus 3 over h. They cancel. Now we can get rid of this when we substitute in h equals 0. We couldn't sub h equals 0 in before because then we'd be dividing by 0, which is undefined. So when we sub in 0, 8x plus 4 times 0 plus 3, which is 8x plus 3. Now, if we did it by the rule, if you know how to derive by the rule, f dash of x, bring your power down to the front, which is 8x. Bring your 1 down to the front and take 1 away from the power plus 3. So that's it. You wouldn't use your calculator to do first principles because if you were trying to find, or you could if you wanted to. So if I said we could define 4x squared plus 3x minus 6, I could define that as, highlight it, you stupid thing. Okay, define f of x, and then we could say f of x plus h, get rid of the z, and then minus f of x over h. And the calculator does that, substitutes it all in, and if you click simplify, it cleans it up. So you get 8x plus 4h plus 3, which is this thing here. And then, I mean, it's not hard to do, but the limit as h approaches 0, it's in math here. So if we put the limit as h approaches 0, and then we put that there, the calculator will work out that it's 8x plus 3. But of course, if you didn't have to show that, you could just get the derivative. And the same thing occurs for this case, for the other case, so yeah. Okay, I'm going to scrub this so I've got a clean screen. Now, here I've got 2x cubed minus 6x. So we know what derivative we should get. We should get f dash of x is equal to 6x squared minus 6, not plus 6. Okay, from there, we need to find f of x plus h, which is 2x plus h cubed minus 6 x plus h. But we know we've got 2x cubed plus 3x squared h plus 3xh plus h cubed minus 6x minus 6h, which is 2x cubed plus 6x squared h plus 6xh. Don't know why this keeps doing funky things. Plus 6xh plus 2h cubed minus 6x minus 6h. Now, none of that simplifies or joins together, so we can say f dash of x is the limit as h approaches 0 of 2x cubed plus 6x squared h plus 6x h squared, there's supposed to be a square there, plus 2h squared minus 6x minus 6h minus 2x cubed minus 6x, all on h. Okay, 2x cubed minus 2x cubed, 6x plus 6x minus 6x plus 6x. So now they've all got a h. So we know, come on, change. We know that we can say the limit as h approaches 0, take out a h, 6x squared plus 6xh plus minus, plus 2h minus 6 over h. Okay, once again we look at what, I'm just going to cross this out, that and that cross out. Now we can sub in h equals 0, so I get 6x squared plus 6x0 plus 2 minus 6, which is 6x squared minus 6. Now that's what we wanted to achieve, because we know that that's what our derivative is. And that is what you're trying to find when you use first principles. Now, a few of you might have been going, what the hell did I do to expand that cubic so fast without actually using a calculator? The trick is, we've got something called Pascal's Triangle. I don't think many teachers seem to teach it anymore, but it's really worthwhile. We start with the number 1, and then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and it continues on. Now I'll explain how it comes about. 1 and nothing, there's nothing there, and then 1 and nothing is nothing there. Likewise, here if I add those two together, I get 2. Add those two together, I get 1. Add those two together, I get 1. Add those two together, I get 3. Add those two together, I get 3. So basically, all you're doing is adding up the two numbers here. So that'd be 10, that'd be 10, that'd be 5, 1, 10, 5, and then 1. Okay, now what's the significance of this? Well, if you have a plus b squared, we know that that's a plus b, a minus a plus b again, which is a squared plus ab plus ab plus b squared, which is a squared plus 2ab plus b squared. Now if you look up here, 1, 2, 1, 1, 2, 1, there are coefficients. Now if you were to expand a plus b cubed, you would get a cubed plus 3a squared b plus 3ab squared plus b cubed. They're your coefficients. So what this allows us to do is expand out binomial terms. We call it binomial expansion, using Pascal's triangle to get the coefficients, and I'll show you what else happens. So let's just say I have x plus 2 to the power of 3. Because it's the power of 3, we need to use that layer. I'll just scribble all over it. So 1, 3, 3, 1. My first term always goes to the maximum power, so x3. Then we take it down 1, x2, x1. Don't need to put the 1 there though. And then x to the 0, well we don't need to do that either, because x to the 0 we know is 1. My second thing starts with the lowest power, so that would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and then we just add them together. So we have x cubed, 3 2s is 6, 6x squared, 3 times 4 is 12, 12x plus 8. Now to do it on your cars, I'll clear this. So we have x plus 2, oops, the minus, plus 2, all to the power of 3. Highlight, highlight, interactive transformation expand, click OK. We get exactly the same thing. On this cars, you need to go menu, 3, 3 first, then put in your function, so x plus 2 all to the power of 3, hit enter, that's it expanded. Okay, now someone always asks, what happens if you have a negative in the middle? So let's try it a bit harder with a negative in the middle. Actually, let's make it decently hard. If I have 2x minus 3 to the power of 4. Power of 4, we need these coefficients, so 1, 4, 6, 4, 1. First term is to the power of 4, so 2x to the power of 4, 2x to the power of 3, 2x to the power of 2, 2x to the power of 1, 2x to the power of none. Then our second term is to the power of 0, to the power of to the power of 1, so negative 3 to the power of 1, negative 3 to the power of 2, negative 3 to the power of 3, negative 3 to the power of 4. And what you will notice is the powers always add to give you your maximum power. 4 and 0 is 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, 4 and nothing is 4. So what we're going to do now is clean it up. So we have 1, negative 3 to the 0 is 1, 2 to the power of 4 is 16, x to the 4. Here we've got 4 times 2 cubed, 4 8s are 32, times negative 3, negative 96x cubed. Here we're going to have 6 times 4, 24, times 9. It's easy to do. 6 9s are 54, and then times 4, which is 200. 6 9s are 54. 216 x squared. 4 times 2 is 8, times 27 is, now that's negative, so negative 216 x. And then lastly, I've got a negative to the power of 4, so it's got to become positive, and 3 to the power of 4 is 81. So that's it expanded without, writing out 2x. Oops. Well, this pen seems like it's really playing up at the moment. Without writing 2x minus 3, 2x minus 3, 2x minus 3, 2x minus 3, and then expanding it, we know we could just grab this. 2x minus 3. Really easy on the cuz. 16x squared minus 96x cubed plus 216x squared minus 216x plus 81. So we did that without using a cuz. And if you do it enough, it becomes second nature, becomes really easy. So that is first principles and Pascal's triangle. Hopefully you understood that, and we can move on to the derivative by rule next. Bye.